Hey guys, so last time we talked about the large and small sample confidence intervals for the means. Let's go ahead and move on to proportions. One note that for proportions, you're never going to have a small sample. You're always going to have a large sample, so don't worry about the T for proportions. The purpose of creating a confidence interval is to provide an estimate for a population parameter. In this case, our population parameter is P, right? Our population proportion. And the sample proportion has some variability, and so we have to come up with an interval because it's not always the case that you're going to have a sample proportion that's equal to the population proportion. So sometimes it's going to be higher, sometimes it's going to be lower. So a quick example is flipping quarters and getting heads, right? And so on average you would expect, and that's why I say on average because it's technically the mean, but on average you should expect 50% proportion, right? 50% heads, 50% tails. But that's not always the case, right? So for example, if you flip 3 quarters, there's no way you're ever going to get 50% of anything because you have to divide it in 3 ways anyways. So that's a quick example of how sample proportions have some variability with them. And so again, some may be higher, some may be lower. That's why we have this interval, because we're not really too fully sure if the sample proportion is the population one. So we come up with this margin of error, which is the next one, how far above and below the interval spans. And this should all be kind of review. We've already seen these statements before. There's a critical z-score, so ZC, that's tied to the upper and lower limits of this interval. And so it's going to be our job to find it. It's going to be the same exact way as we found it before. And so why not, let's just get to that point. To find the z-critical, you follow the same procedure that you did with large sample confidence intervals for means. Right? And so you just look up the confidence level over 2, and you're good to go. So let's come back up here though. So our margin of error is the critical z times the standard error. So again, it's very similar, and that's why I like to do is keep everything very much the same, I guess. And so you're going to see the margin of error is just the z times the standard error, just like before, but this time our standard error is a little different, right? So we have mean of the sample proportions is the population one, so on average you would have this proportion, but again there's some variability, right? And then the standard error, so before we use just P and Q, the population estimates, but here we don't have P and Q, right? We're trying to estimate P. That's why we're coming up with this interval to begin with. So our next best guess for what the standard error would be is to use the P hat and Q hat, which are the sample proportion and sample basically failure of the proportion. So you're going to use P hat and Q hat as your standard error, but just for confidence intervals. If you're trying to find a probability, you're going to have the population proportion. Does that make sense? So that's why you use PQ over N, versus here you don't know it. That's why you're coming up with this confidence interval, because you're using your sample information to come up with where the population parameter lies. So here we use P hat and Q hat over N. And that's about it for that. So then we're going to have our P hat here. Here's our P hat plus the margin of error. Here's the P hat minus the margin of error. And there's going to be z's associated with both of these, right? And so again, we're given a confidence interval, or confidence level, I'm sorry. So here's our confidence level. And then, basically, the same thing happened before. We're looking for the probability from 0 to z because that's what our table works off of. So to get a z-score, you have to get that area first. So if the whole green and yellow is confidence level, basically the yellow part, which is what you need for the table, is just the confidence level over 2. So again, this is where you're going to look up. It's just CL over 2. Cool? So let's just do a quick example. And the reason I did one is because by now this process gets very tedious. So I don't want to put a bunch of examples because they're all pretty much the same. So let's get started. A survey of 200 people revealed a 45% preference for Apple computers over Windows computers. Construct a 98% confidence interval for the proportion of people who prefer Apple computers. So here we go. We have in the middle our estimate, right? Our estimate for our population parameter. So here's going to be the 0.45. These are all a bunch of P hats and Z's. So what should 0.45 get? It's going to have a 0, right? Cool. So we want a 95% confidence interval. So that means, here's our cute little interval. We got 98% is in between these bad boys. And again, we're just going to look up half of that, right? So let's get the z critical, because that's our first step anyways. We just have to get the critical z, and then we work towards our margin of error, and then we get the full confidence interval. So z critical, we need the confidence level over 2, so it's 0.98 over 2, or 0.49, right? So once we get 0.49, we can look that up in our table. So let's just go down a little bit. 0.49. So do I go to 0.4 and then go across to 9? No, right? Because that would mean that 0.49 is a z-score, which it's not. We're trying to get a z-score from that probability. So we go to 0.4900, the closest thing to it. 49. So we're kind of in between these two. We're looking for 0.4900. So 4898 is 2 away, 4901 is 1 away, so we're going to use the 4901, which ends up giving us 2.3. We go up, 2.33. So that's our critical z-score. So we got 2.33. So here's 2.33, here's negative 2.33. And now we work towards our margin of error, right? We want to see how big above and below does this interval span from my sample proportion. So margin of error is the critical z times the standard error of proportions. But we don't have that yet, right? So let's go ahead and get that first. So our standard error for proportions is the square root of p hat q hat over n. Right? So p hat is 0.45. Q hat is 1 minus that, so 0.55. And all over the sample size, right? So our sample size in this case is 200 people. So once we do all that cute math, so you can just do it all together, press enter, and then do square root of all that stuff. And I'm talking about doing it on your calculator, because sometimes these things get a little tricky and you get nervous, whatever. So you get 0.0352. So some of you may be asking how many decimals should you round it to. With proportions, I would suggest rounding it to at least 4, just because since proportions are already such small numbers, right? A proportion goes from 0 to 1, right? So 0% to 100%. Since they're so small, very tiny variations in your answers as you're rounding throughout the process can make a big difference. So if you cannot round, that's basically the best option, is to just not round throughout the whole process. But for here, just so I could write some numbers, I'm just going to round it to 4, and 4 is a pretty safe decimal because it still gives you the same z-score. The same standard error. So 0.0352, our z is 2.33. So once we multiply these out, we get 0.0820. So now all we do is the sample proportion plus or minus that error, right? So p hat plus or minus the margin of error. So we get 0.45 plus or minus 0.0820. So we end up with 0.5320, right? And then 0.3680. So we're 98% confident that the true proportion of people who prefer Apple computers over Windows lies between 36.8% and 53.2%. That makes sense? So it's very similar. The only thing that changes really, again, is just the standard error. Once you calculate the standard error, you're good to go. So that's about it for large sample confidence intervals for proportions. And we're actually done with confidence intervals, so that's good. Let's go ahead and move on to some practice problems.